In the previous lecture, we've derived the general equation of motion, especially the non-dimensional form of the general equations of motion, and grouped them into the longitudinal equations and the lateral directional equations. In the second lecture here, we are talking about the longitudinal equations. Okay, so this is what we had from the previous lecture, longitudinal equations and the lateral directional equations. And as I said, we're looking at the first three equations. That's for the longitudinal motion. Okay, so there are two types of stabilities, and the stick-fixed stability and the stick-free stability. What's the difference? So and according to their name, stick fixed stability, there's no stick motion, which means there's no elevator movement for the longitudinal stabilities. But for stick free stability, the elevator is free to move. So in this case, the right hand side of the equations is 0. So in here, we are only discussing the stick fixed stability, and because this is makes the right hand side being narrow, and it's easier for us to analyze, to do the analysis. Okay. So similarly, we can assume the response or the solution is in the form e to the power lambda t. T is in the non-dimensional form, for example. And then each quantity can be expressed. So we have u hat, that's a non-dimensional velocity disturbance, and equals k1 times e to the power minus t hat, and for w and for theta. And also we need to know the non-dimensional derivative. And so here is a very quick derivation, and we know the temporal derivative of u hat in the non-dimensional form is lambda u hat, and the second derivative is lambda square u hat. Okay, so this is a preparation we make. Now what we do is just plug in. Now we have the target, and we know we assume the solution is in these forms. Okay, so for now we just plug in the solution into the equations, and we can simplify the above three equations, governing equations, into the format as attached here. Okay, so now we are looking at these three equations in the bracket. Okay, so let's go further. And we can write these three equations in the matrix format. And okay, so for now, the objective is to solve the above equation and determine lambda, k1, k2, k3. So these are the three unknowns we are interested in, and especially lambda is important. So how can we solve these three equations? And apparently, if k1 equals k2 and equals k3 being 0, and it's apparently one solution, but it's useless. It's not useful. Okay, so see, how can we solve it? In order to solve it, now we need to let the determinant of the coefficient matrix being 0. So this is what happens. The coefficient matrix being 0, that allows, it apparently makes the equation true. Okay, so the determinant is essentially a quadratic equation for the determinant on the left. So if we assume, as we know it's a quadratic equation, we can write it in this way: a lambda 4 plus b lambda 3 plus c lambda 2 plus d lambda plus e equals 0. So this is a format we can assume. And now what we do is we just expand the determinant and compare with a, b, c, d, e. And so we can have a is 1 and b, they are relations. So this is what we have so far for the longitudinal equations. And now the task is to solve the quadratic equation about lambda. So because if we know lambda, then we can find the period time and damping ratio, something as those informations. Okay, so this will be discussed in the next lecture.